Hello friends, how are you all? Today we are going to discuss the chapter current electricity. So before starting this chapter, let us first of all introduce this. What is current electricity and how we are using this electricity in different ways. First question arises, what is electricity? What do we mean by the term electricity? Actually, electricity is a type of energy, or you can say it is a source of energy, and nowadays we are fully dependent on it. How? You are knowing, we are using so many devices in our everyday life which is run purely by electricity. So let us collect all those instruments which we are using in our everyday life, in our daily life, which is run by this electricity. As you know, around you there are so many devices like heater, electric iron, mobile phone, refrigerator, electric train, AC, cooler, geyser, and so on and so on and so on. So there are so many devices which is working with the help of electricity, and we are purely dependent on it nowadays. And without electricity we can't live. That is, our life will not exist without electricity. So before entering into this chapter, because as you know, electric current is the basic identity of matter, or you can say one of the fundamental physical quantities. In class 9 you have read, electric current is one of the fundamental units, or you can say base physical quantities. And electric current constitutes of charges. That is, flow of charges is called as electric current. Is that clear? Flow of charges is called as electric current. So, first question arises, what is charge? So, let us discuss what is charge. Then only we will further move towards this electricity. Charge. Everybody is knowing that matter can exist in three states, that is solid, liquid and gas. Matter can exist in three states, that is solid, liquid and gas. And if we break the matter, ultimately at the final stage we will get the charges. For example, let us take the best example. In our daily life we are using chalk. CHALK, chalk. If I break the chalk, what I will get? Again I will get chalk. Again if I will break, then again I will get chalk. If I rub the duster in the blackboard, I will get chalk dust. And when a single chalk dust is divided into million parts, I will get calcium carbonate, which is the chemical symbol of chalk. Is that clear? This is calcium carbonate. You can say this is the molecule. It is in molecular form. And as you know, a molecule is composed of different atoms. Here in calcium carbonate, you can say this is in atomic form, that is calcium. This is also in atomic form, this is carbon. and this may be taken as molecular form, or but here it will act as in atomic form, that is oxygen. Is that clear? Now chalk is divided into chalk dust. Again chalk dust is divided into lakhs of millions of molecules, and let us consider only one molecule. Again one molecule of chalk may be divided into calcium, carbon and oxygen. Again if I break this calcium atom, then we will find electrons, protons and neutrons. Similarly, if I break carbon atom, I will get electron, proton and neutron. Similarly here also. So in every atom we will get electrons, protons and neutrons. So these are originally charged particles, electrons, protons and neutrons. Electron is negatively charged particle, proton is positively charged particle and neutron is chargeless. This is having zero charge, or it's called as chargeless particle. So charges are of two types generally. One is electron, second one is proton. Is that clear? Now let us discuss what is the charge of a single electron. The charge of a single electron is 1.6 into 10 to the power minus 19 coulomb. Similarly, charge of a proton is also equal to this much. This one is negatively charged, please keep in mind, and this one is positively charged. And in magnitude, both are same. The magnitude of an electron and the magnitude of a charge of the proton, both are same. That's why a very good question arises, an atom is electrically neutral always. This is because of this. You have read in class 9 in chemistry, an atom is electrically neutral because it contains equal number of electrons as well as equal number of protons. So this is all about your charge. Similarly, what is the mass of an electron? This is 9.1 into 10 to the power minus 31 kg, and mass of a single proton, this is 1.67 into 10 to the power minus 27 kg. This is all about this electrons and protons, but still the definition of charge remains. What is a charge? Charge is the basic identity of matter, or sometimes it may be defined as the building block of matter. Building block of matter. That means if we break any type of matter, that is solid, liquid or gas, at the last or at the final stage we will get this charge. And types of charges, this is negative charge, this is positive charge. Negative charges are called as electrons and the positive charges are called as protons. Secondly, the definition of charge is there. Now, what is the denotation of charge? How a charge can be denoted? The denotation of charge. Charge can be denoted by the symbol plus Q or capital Q or small q. This is the denotation, this is the symbol used to denote this charge. Second thing, charge is a scalar quantity. Charge is a scalar quantity. Do you know what is a scalar quantity? Scalar quantities are those quantities which have only magnitude but do not have the direction. So charge is a scalar quantity. Now let us read the properties of charges. Properties of charges. Number 1, like charges repel each other and unlike charges attract each other. Like charges, please note it down, like charges repel each other and unlike charges, unlike means opposite charges, like means same type of charges, that is like means you can say plus plus or minus minus. Unlike means you can say plus and minus. Unlike charges attract each other. Second property is like this: quantization of charge. What do you mean by quantization of charge? As you know, this is quantization of charge. Quantization of charge. It means, let us consider any object or any substance, and the total charge of that object always exists in discrete packets. Discrete packets. What does it mean actually? Discrete packets. That means the total charge, you can write down the sentence, the total charge of an object is always the total charge of an object is integral multiple of an electronic charge. That is, mathematically it is written like this: Q is equals to plus minus Ne, where Q stands for total charge of the object, N stands for number of electrons or number of charges, number of protons you can say, and E stands for charge of a electron. And here plus sign, if I take plus Ne, means it's proton, minus Ne, it's number of electrons. So both protons, both positive charges and negative charges are constitutes in the object. So this is the total charge. And by using this formula, you can solve the numericals like what is the number of electrons present in 1 coulomb charge. Yes, perhaps I have forgotten. What is the SI unit of charge? The SI unit of charge is coulomb. It is denoted by the symbol C. The CGS unit of charge is stat coulomb. SI unit of charge is coulomb, the symbol is C, and the CGS unit of charge is stat coulomb. So, based on this formula, what is the number of electrons present in 1 coulomb charge? So, the given data is like this: Q is equals to 1 coulomb, E is equals to 1.6 into 10 to the power minus 19 coulomb. Why I have not given any negative sign? Because this is always written in magnitude format, because this is a scalar quantity. Now N is question mark. So by putting in the formula 1 coulomb, this is N into 1.6 into 10 to the power minus 19 coulomb. So N is equals to 1 by 1.6 into 10 to the power minus 19. By solving this, you will get, that is 10 to the power 19 divided by 1.6. Again this is 100 by 16 into 10 to the power 18. Try to manipulate. I have taken 110 from here and again 110 from here. So ultimately the answer is 6.25 into 10 to the power 18 numbers. This is the number of electrons present in 1 coulomb charge. So you can use this question, or I am giving some homework to you. What is the number of electrons present in, instead of 1 coulomb, 1 millicoulomb charge? This is in A. Second question is 1 microcoulomb charge. Milli, micro, you are knowing. Milli means 10 to the power, milli means 10 to the power minus 3, micro means 10 to the power minus 6, similarly nano means 10 to the power minus 9, and again kilo, this is 10 to the power 3, mega, this is 10 to the power 6, and giga, this is 10 to the power 9. So, dear students, this is the homework for you today. So, we are going to stop here. Thank you very much.